Start with RTP and RTCP and so on. So what is RTP? RTP full name is Real-Time Transport Protocol. In a nutshell, it is used for transport of real-time data, audio, and video. It contains these three main parts in the header of this protocol. First is port number, a sequence number, and a timestamp. Other facts about RTP. RTP typically runs over the UDP protocol. That is, we make modifications in UDP because it is not it is very because it is not reliable. So we make modification to it. Hence, it works along with RTP. RTP was developed by the Audio Video Transport Working Group of the Internet Engineering Task Force (IETF), and first published in 1996 as RFC 1889, which was then superseded by RFC 3550 in 2003. As we are still using this RFC 3550 till these many years. So in detail, what is RTP and RTCP? So I'm going to explain RTP in how the process work. So there are two systems who want to communicate with each other. For example, we are now right now communicating with Teams. So on the one side, for example, sender side, system will take a port information. As I told that it has a port number in the header, port information, sequence number, and it will gather it on the other hand, and we will resequence the packets which were lost. So this was the this is what we need. UDP had not reliability in it, but this port information, this sequence number, uh, and the packet lost will be gathered on the other hand system, that is on the your hand. And it will resequence the packets and replay the lost things. So it will make it reliable along with UDP. It can play them back, as I said. It can play them back in their original order. It uses jitter buffer, periodic signal. The jitter buffer is something that in a periodic graph, whenever there is a unwanted change, so we call it as a jitter, and so we get reliability, and it is what we need. It is what we needed. Second point. Now, for a voice conversation, system will take random UDP port with specifications as an even number in range 163084 and 32767. So, for example, we are right now communicating. So my system will take a random UDP port, which will be even and in this particular range. It can be even in this particular range. Both side system will do the same. So your particular system also will take a random UDP port, which will be also even. So we are talking right now about two unidirectional communication scenario in a nutshell. So let's keep this in mind. For example, a port is taken by system that is 16384, which is even, and it is in this range. So this is an RTP packet example, which is from Wireshark. So this is it is provided. These details are provided in Wireshark. So real-time transfer protocol. There is this version of RFC, as I told earlier in the slide. So there is a padding, sequence number, and all those synchronization SSC, and this all stuff, which is part of this RTP header. That is what RTP header contains. So this is the structure of RTP header, RTP packet format. So here is padding and sequence number, time step, SRCC, and this is the actual example. Like I was capturing RTP packet, and this is the format, and this is the actual example in Wireshark. So as I explained RTP, now let's move to the RTCP and SRTP. What is RTCP? RTCP full name is only one change: Real-Time Transport Control Protocol, aka sister protocol of RTP. So why is it called sister protocol? I will explain uh, uh, in a moment. In a nutshell, RTCP is used to monitor transmission statistics and QoS, quality of service. So it basically RTCP basically it contains the statistics of a particular RTP session. So it monitors this transmission statistics, and it also maintains the quality of service. It main part of header contains statistics of transmission and information on packet loss. So it is RTCP who is going to inform us the packet loss during the RTP session. Other facts about RTCP: it controls the information about RTP session. As I told, that is, it is monitoring transmission, periodically sending statistics, information packet counts. So what statistics it contains? So these are the statistics it contains. It contains the packet counts, packet loss, packet delay variation, and round trip delay time to participants in a streaming multimedia session. Now, some points about RTCP. RTCP also has a port number which is derived from the port number of that of RTP. So, as we assumed one RTP UDP port about in the RTP section, so it is E1 16384. So there is a relation between RTP and RTCP. There is always going to be two UDP ports selected, one for RTP and corresponding port for RTCP. So if RTP port, as we know, it is even, so corresponding RTCP port is going to be one more than the RTP port. That is, if we had a 16384, which was even, which was for RTP, so corresponding RTCP will be one more than that is 16385. So the specification is RTP port number is going to be odd. So although this is not the case always, this is not the case always that RTCP number is added by one that of RTP. This is an RTCP packet example. Here it is written the RFC version and padding and all the synchronizers header part is shown here. So let us move to the practical part. Before that, this RTCP and RTP is not secure. It is not secure. So let's see why it's not secure and what is the solution. So RTCP and RTP is not the end. RTCP is going to inform statistics of the call, as I said earlier. RTP or RTCP is not secure, but we do have a secure protocol method. It is an extension protocol which provides replay protection. That is, we are playing the packets back. We need the protection. In RTP and RTCP, there is no protection. So there is a replay protection, not only this protection, and there are other protections too. There are so many to the RTP and RTCP traffic. So let's see. First, let's see this secure real-time transfer protocol. That is, we add S to the our RTP and RTCP. So SRTP, so it is secure real-time transfer protocol. In a nutshell, we can say it is made to provide encryption, message authentication, and integrity and replay attack protection to the RTP data in both unicast and multicast applications. So that was the disadvantage or drawback of RTP and RTCP, that it was not secure, but we have another protocol which is working along with RTP and RTCP, which is SRTP. Some facts about SRTP is, since RTP is accompanied by RTCP, which is used to control RTP session. Similarly, SRTP has a sister protocol called a secure RTCP, that is SRTCP. So now you can understand why RTP and RTCP is a sister protocol of each other. RTP works, but RTCP, that is going to inform along with the communication that packet is lost, and we need to retransmit the packet and do the original version of the packets. So it is a sister protocol. That's why name is given as sister protocol, because it works along with it. So SRTP it securely provides the same function as STCP as the one provided by RTP to RTCP to RTP. So I mean to say that the same relation between RTP and RTCP, the same relation has RT SRTP and SRTCP. So they have both the same thing. The only thing about this one is that it is secure. So let us see. I have told earlier that it takes UDP port number. For example, there is a voice call, and both has unidirectional transmissions. So system one will take a UDP port number, which is E1, and on the other hand, it will also take a UDP port number, which is going to be E1. We are going to see RTP and RTCP packets in Wireshark in a few minutes. I also have a jitter graph here. So this is there is some standard periodicity of this graph. Now, if that is, as I told, we have unwanted change in periodicity that is called jitter. So this is the jitter. It is caused by packet loss. So overall summary of this presentation before we move to practical. So RTP adds reliability to UDP. We made UDP modification to UDP. We have RTP. Then we want to want information about packet loss. So we have RTCP, which is going to control and give statistics about RTP sessions. Then we don't have security in this, so we moved to SRTP, which adds security to RTP and works the same way as this, just additional security. And similarly, there is a SRTP, which is a sister protocol of SRTP, which gives statistics of SRTP, but in secure way. Okay, so I'm going to show you the practical now. So as we are communicating with Microsoft Teams now, so I need a IP address of Microsoft Teams in this network. So if I do some activity here, action here, so uh, I can see this the Microsoft IP address is 52.113.194. So for a second, remember this 52.113. So now I'm going to open Wireshark. And I am connected to Ethernet, and I'm starting the capture. So you can see RTP and RTCP packets, and these IP address, as I have told you, in these. Let me show you again. As I showed you earlier, I need to close it bit.
I think 2 students are left now only.
Okay, sir.
Number just
Yes.
roll number 40, Jeet and Vatsal. Correct? Am I correct?
Yes, sir.
So this is the IP address, which is from Microsoft team that we are communicating right now. So you can see this capture this IP address right now. So there are some RTP and RTCP randomly here. So this is a report. RTCP contains the statistics of, and it gives the report. So in detail, I have already posted the screenshot of this part, but let's see. So this is the port I was talking about, the UDP port. This is the source port 65320. This particular packet I have selected 4410 packet. There is one RTCP packet which has the UDP port 65321. That is one more than this in these statistics. As I told earlier, it is not the case always, but in the references there is told that it is RTP port is even and RTCP is odd and one more than this one. So this informations about that RTP protocol. This is a padding, then sequence number, then SSC synchronization source, and you can see this packet RTP packet format for this particular selected one packet. And if I want to show you the jitter part, So this is the RTP stream analysis. So this is the RTP stream analysis, which has packet counts. This is provided by RTCP actually. Then sequence numbers, then delta, jitter. I was talking about bandwidth, marking, and status. So this is the graph. I guess I will see in RTCP packet in that jitter part thing. Or
Yeah, but whatever you select, the graph only gives you the report of only the selected packet.
yes, sir.
So that is no worry. It's a RDB packet only. So you have to string, you have to filter RTCP packets.
Yes, sir.
Yeah. And whatever graph you will get, it is RTCP.
But it is not showing the graph right now. I don't know why.
Just
But
RTCP packets are very low in
less.
number. That's why.
Okay. Yes, yes. It cannot make the graph because of less
Yes, it's a
statistics.
nearer to zero. If you
Yeah,
look
yeah,
at
yeah.
that graph, it is
Okay,
near
sir.
to zero.
Yeah.
That's why.
So
Good,
that
good
is,
day.
thank you, sir. So this is the information about RTCP protocol. It also has similar header to that of RTP protocol, padding and sequence number and stuff like that.